We'll now see how to work with vectors and matrices. First, we will see that sum and multiplication are defined as in mathematics. In addition, it is also possible to do operations element by element. We first consider basic vector operation. You can define vectors, for example, column vectors. So vec_col equal, and then I have to use the brackets as we've seen before, and we separate each entry by a semicolon. And then I hit enter and I see my column vector. I can also do a row vector. So the syntax is very similar. I type vec ligne, which in French means row, equal to brackets. And now instead of semicolon, I have to use space, or, this is new, a comma. The two things are exactly the same. So -2, 3, 4, I close the brackets, and then I have my row vector. I can define v as my vector row, so I can redefine, I can define a new variable and then have a look at the size of this variable. So if I type size v, then I get 1, 3. So it's a 1 by 3 matrix or a row vector. And if I have a look at the size of my row vector, then it is 3 by 1. So you have 3 lines and 1 column. I can also define a variable a as being a vector between 1 and 4, but with all the entries in between. So -1, 4 gives me -1, 0, 1, 2, 3, 4. So this is a shortcut to actually define a vector with 6 entries. I can also define vector b, which is similarly defined, but with spaces which are not 1 but 2 here. So I define the vector b as -0.5 by 2 until 3, and then I have -0.5 and 1.5, and then stops, because the next one would be 3.5. So if I change this and arrive up to 5, then it stops at 3.5. Why? Because 5 is the upper limit. It is not the last number. So it is not always reached. If I write that b is -5 by 2 until 3.5, I get exactly to the same number. Each time here we redefined the variable b, so it's always a new one. So every time I do equal, the last variable b is crushed in the new one, and the new variable stays there. There is also another way to define equidistributed vectors, for example, by defining c equal linspace. So this is a built-in function, and I have to give the beginning, the end, and then the number of elements that I want. So this will define a vector which is exactly 1 times 4, which goes from 2.1 to 4.2 with equidistributed numbers. So now we'll see how to manipulate vectors. First I clear my environment with clear O. Okay, so this will remove all my variable, and I can define a new one, a, which is equal to -1 up to 5 with an increase of 2. So this is -1, colon 2, colon 5. And at the end I put a semicolon so that I don't see what is actually done, but I know that this is a equispaced vector A. Then I define a second vector B, which goes from 0.5 by steps of 1.4 up to 6. So same notation, and I don't want to see the result, so I put a semicolon at the end. Now I would like to form one single vector with the A and B together. So how can I do that? Well, I say C, I use the brackets as before, and instead of writing numbers, I write the variables that I want to concatenate. So this is concatenating variables. And since I put a comma between them, then these variables will be put, the two row vectors give a row vector with one line. Now I can also extract values from this new variable c. So I can take c3 and it gives me the third element of this vector. I can even have a new vector x which is equal to sum of the entries of c. For example, I want to take the second, the fourth, and the fifth entries of c. So this is how I can extract those entries, and I have my new vector x, which is a subset of the vector c. So I have these entries, which are the 4 entries of c that I have extracted. I can also transpose a row vector and then obtain a column vector. Of course, if you transpose a column, then you get a row, and if you transpose a row, you get a column. So the symbol is this dash, so x dash. It gives me the transpose of x, which is a column vector. It's exactly the same entries as before. So this symbol is not the derivative symbol, it's the transpose symbol in Octave. Let's see now how to do sums and scalar multiplications. I clear again my environment, and then I define two vectors. A as a column vectors with 3 entries, so I have to use semicolons. So I have -3, 2, 1 in column, and I put a semicolon, and then B is a second vector of the same size. I define them in the same size because I'm going to work with A and B together. For example, to the sum, I have to be the same size, otherwise it's illegal to do a sum. Okay, so now I can do C equal A plus B, and I get a vector which has the same size as A and B, of which entries are the sum of the entries of A and B. I can also multiply by a scalar. So if I say D is equal to 3.2 times A, then I get that each entry of A is multiplied by 3.2, and I get a vector of the same size of A. So it's a column vector with 3 entries. So as I said before, if we want to do the sum of vector, the sizes have to be the same. If I have a vector that is too long, for example, I take a long vector which is equal to the concatenation of A and B. So I've taken A and B concatenated by semicolons, so I get a big column, and I try to do A plus this vector longer, then there is a mistake. There is an error, and Octave tells you where you cannot sum these vectors. There is a particular vector which is the 0 vector. Okay, so I say vec null equal to zeros, then I have to tell the size. So I say size 4, 1. What does it mean? It creates a 4.1, so a column vector with 4 entries, and all are null, are 0. I can also define a vector of 1. This time I would like a row vector. So it's a ones 1, 4. Again, here the size is 1.4. Is a row vector with 4 entries and all equal to 1.